Okay, thanks, Milo. I'm glad you came up with a funny anecdote just in time. It is true. I started as a professor when I was 25 years old, so I was young when I started. Not anymore, unfortunately, though. So today I'd like to talk about some of our recent work on answering why questions about narrative text. And this is joint work with a variety of people. As part of a DARPA Kairos project, I'm on a team. The lead institution is Stony Brook. So there's a number of people there. Yash is the graduate student there who did most of the real hard work on this project. His advisor is Niranjan Balasubramanian, and a couple other students there helped out, Horace and Tanvi. And then Nate Chambers is at the Naval Academy, was also part of our team and involved in this. And then we wrapped in Mikat Tandon at AI2, the Allen AI Institute. Okay, so there's been a lot of progress, particularly in recent years, on deep learning methods for question answering from text. Most QA concerns questions like who, what, where, and when that typically have an answer that you can sort of directly extract from the text. In fact, some of these corpus like Squad, you have to extract the answer from the text. But answering why questions, I feel, is quite a bit different. It's less well studied, and it usually requires reasoning and common sense knowledge. It's not explicit, and you can't just extract something from the text that answers a why question. And I'm particularly talking here about why questions about narratives, about stories about what people do and why they do the things that they do. Now, this whole topic of why questions about narrative text is not a new thing. I really care about the history of things, and I've lived a lot of the history of AI, maybe too much of it, unfortunately, at this point. And I always like to educate the younger people about this history. So in the 70s and 80s, there's a fairly large body of work in natural language processing on understanding short little stories. And that work was sort of what's called GOFAI. Anyone know what this expression stands for? Make this a little more interactive. GOFAI. Yeah. Good old-fashioned AI. That was the tradition I was brought up in. Logic, symbolic, but the problem with GOFAI was the typical argument was brittle, right? You could engineer a set of knowledge structures that would take one piece of text and understand the hell out of it. But if you tried to just move the text a little bit, the knowledge sort of wasn't quite relevant that you had engineered, and it just fell off a cliff, right? It just wasn't robust. And what a lot of neural net had, by learning from tons of data, you make systems a little more robust, but I feel sometimes not as deeply understanding things as what these old systems did. Whoops. Yeah, so I gave this I thought it was an interesting presentation. I think a lot of people did, at this event called NLP Idol, Plucked from Obscurity. Of course, it's a pun or whatever on American Idol, right? But this is a competition between, researchers in natural language processing. This is at NACL, the North American Association for Computational Linguistics, 2012. So it's now a little more than 10 years ago. And they set up meant to be a fun event, right? Where they had 4 contestants. It was actually me, Eugene Charniak, Graham Hurst, and Mari Ostendorf, for people who know people in the NLP community. Mari's more of a speech person. I don't know her as well. And you have to pitch an old, underappreciated paper that modern NLP researchers should go back and read and reconsider. And I pitched this old paper based on what's called plan-based story understanding. Tries to understand stories by understanding the plans and the goals of the characters in the story. By Bob Walensky. A lot of people don't know Bob these days. He passed away quite a while ago. He was a prof at Berkeley, but people know a lot of his former students like Dan Jurafsky, Marty Hurst, a bunch of other people. I learned about this from a textbook that I used in an NLP class in the 80s called Inside Computer Understanding. Roger Schenck was a very influential early researcher in natural language processing. He did a lot of work on understanding stories, and a lot of his students have spread throughout the country and had descendants. And he is my academic grandfather. He was my thesis advisor's thesis advisor. Unfortunately, Roger died just literally like 2 months ago. I think he's about 76. Interestingly enough, just a week or so, a couple of weeks later, his advisor passed away. His name was Jacob May. He's 96 years old. I got to know Jacob because he happened to be in Austin, where I am. Because guess where Jacob May was a professor and Roger Schenck was his PhD student. We had a Longhorn in the audience. Where is she? Yeah, UT. This is our hand symbol. It's not profane. It just means hook 'em horns. Apparently in the Netherlands, this is a profane gesture. You can imagine what it might mean. I can tell the story about how I learned that, but anyway. I made a pitch that this old paper, people should go back and read it and think about the issues that it raised. And I did such a great job. I won the judge, but there was a judges. Jason Eisner portrayed a sort of Simon Cowell clone. He was like put on a fake British accent and made obnoxious comments about everybody's talk. People in the community know Jason, obviously. And then they had an audience vote. I definitely won both. I couldn't get Ellen Rylock, who was the program chair who ran it, to tell me exactly I think I won the judges unanimously. I wanted to know what fraction of the audience voted. I didn't just win. I wanted to decimate the other contest. That's actually a bad news because decimate actually means only like 1/10. But she would never tell me what the vote was. But I won. And I got a big bottle of Canadian syrup because it was held in Montreal. I always have to mention, I forgot to mention, I gave a talk at ISI yesterday, that I've also won AI Family Feud at AAAI. I was part of the winning team for AI Family Feud. They're both on my Vita, so you can look up the dates on that. That was supposed to be fun. So PAM was a system that constructed so-called plan-based explanations of characters' actions based on reasoning about their goals and plans using good old-fashioned AI techniques and AI and planning that originated with the STRIP system at Stanford Research Institute, where you have actions, there are preconditions and effects. Actually, Dara and I were just talking about some of this sort of stuff right before this, and reasoned about the actions that the people do in terms of how it helps, how the actions chain together to form a causal chain that accomplishes some character's goals. And based on that, it could answer why questions in a pretty intuitive and convincing manner. So I had to go back to this old textbook, scan in, a page from it, because you didn't have PDF back then. You get this short little story. John wanted money. He got a gun and walked into a liquor store. He told the owner he wanted some money. The owner gave John the money, and John left. You can ask these questions. Why did John get a gun? Because John wanted to rob the liquor store. Why did John threaten the shopkeeper? Because John wanted to get some money. Why did the shopkeeper give John the money? Because the shopkeeper didn't want to get hurt. Why did John leave? Because John didn't want to get caught. Blah, blah, blah. It actually has pretty good answers to these things. So I did my thesis at another great university, the University of Illinois Urbana-Champaign in 1987. We at least have one Illinois PhD grad here. Anybody else in Illinois? Illini? We don't have a hand symbol. No, we have two Longhorns and only one Illini. It was using plan-based understanding. I developed a system called Genesis. You had to have a cool acronym. It's sort of back to acronym era. So the acronym sort of went out of favor for it. Generalizing explanations of stories into schemata or something like this, which use plan-based understanding like in PAM, produce explanations, but then generalize those explanations into schemas or scripts or sort of larger abstract knowledge structures to capture the structure of the knowledge that helps understand that story. So the example schema that it learned or concept or script was kidnapping. And it never knew the concept of kidnapping. It just had underlying knowledge structures that help it understand the plans and the goals in this story about kidnapping. I won't read through this somewhat longer story. And then constructs this graph structure that I called an explanation that shows the goal of eventually, getting money here, possessing this money, and how it is a plan that was achieved to do that by engaging in this bargain, which relied on a number of beliefs and particular characters having goal priorities, one thing more than another, and that was based on inferences. But the knowledge needed to construct this I all hand built it. What was the preconditions and effect of a bargain? Use this thing called strips operators, for anyone knows classical AI planning sort of stuff. And it would construct this explanation. from that story. And then it could do a really good job, I feel, of answering why questions about that story based on its explanation of how the character's actions contributed to their achievement of their goals. So you could ask, why did John aim the gun at Mary? So John could threaten to shoot Mary with the gun unless Mary went from John into the car. Why did Mary get into the car? Because Mary wanted not to be shot, and because Mary believed, notice the pronominalization is not great here, that if Mary did not go from John into the car, then John would shoot Mary with the gun. Why did Fred give John the money? Because Fred believed that if Fred gave John the money at Trina's, then that was a restaurant in Champaign-Urbana. I don't think that disappeared a long time ago. This was the 80s. Who remembers the 80s? I do. Then John would release Mary, and because Fred wanted Mary to be free more than he wanted to have the $250,000. Okay? But the problem with all of this, like I said, is brittleness, right? I engineered a set of knowledge that could help it really construct that explanation. If you varied the story too much and it needed another piece of knowledge you didn't have, it all fell apart. But I think when it did understand and it had the right knowledge, it produced these beautiful explanations and had these beautiful answers to why questions. I would argue still better than the best sort of techniques out there, but we'll get to data on this in a minute. Okay, so that's my review of the past. And it is a very personal story because, I wrote my thesis on this, and you always, your thesis topic has a place in your heart for the rest of your career. So more recently, what we've tried to do is go back to these issues of trying to answer why questions, which I think, like I said, I don't think has been really that well addressed yet. And build a reasonably large-scale data set of why questions about short narratives with gold standard answers from humans annotated with it. And we tried to test how well, quote, current. Now, the original paper on this was a year and a half ago. It was ACL 2021. And then I'll update it because I'll talk about that, the data set and initial results. Then we had a paper at EMNLP that's not that old. It just came out in December. We looked at trying some other models, more modern, but not up to date because I don't have ChatGPT results. I actually say I call ChatGPT the system that should not be named because I'm just tired of hearing about it. That was supposed to be funny. Sorry. So yeah, I mentioned in another talk, and somebody said, yeah, it's like Voldemort, now, of course, we not only have to do that, we have what as of like 2 days ago? GPT-4. So, stay tuned. It's hard. ChatGPT just came out with an API like last week. And so we're still trying to update these results. So just, I'm not going to talk about the system that shall not be named and the new system that shall not be named, and what, we can talk about it in the future. But there we developed methods for injecting common sense knowledge from an existing knowledge base into these models to help improve their performance. We use this system called Comet, developed at the University of Washington. I'll talk a little bit more about it. Okay, so why questions? I've obviously asked that question. Well, here's a sample story. We use stories from this corpus called Rock Stories that came out of Rochester. Rudy was convinced that bottled water all tasted the same. He went to the store and bought several popular brands. He went back home and set them on a table. He spent several hours tasting them one by one. He came to the conclusion that they actually did taste different. Then you ask the question about all these events. Why do you do this? Why'd they do that? Why? It's like a little kid. Why did Rudy go to the store and buy several brands? So one of the human answers that we got collected from humans was he wanted to do a taste test. Like I said, there's a long history of that understanding plans and goals and answering why questions is really critical to understanding text, particularly understanding narrative text, stories about people doing things. Why do they do those things? A couple of cognitive psychologists who looked at this, Kinch and Dyke, wrote all about this sort of stuff back in '78. My academic grandfather, Roger Schenck, and another psychologist at Yale, Schenck and Abelson, wrote this book called Scripts, Plans, Goals, and Understanding in 1975. It was sort of a classic of its era. But there's really, until we did this work a year and a half ago, there was really no large-scale data set of why questions about narratives. There's other types of why questions, and we can maybe talk about that. But here I'm talking about why questions about stories, why people did things. Not like, why is the sky blue or something like that. So we built this corpus called Tell Me Why. We took Rock Stories, a set of stories from the University of Rochester, collected We posed questions about all events in that story. We collected answers from 3 human judges. We then we got answers like that, and then we had 3 other humans judge how grammatical those answers were, and whether they were a valid, reasonable answer to why the person did those things. And we had to rate them on a Likert scale of -2, meaning it was horrible, up to +2, which means it was great. Okay, so I think we got some pretty good data out of this. And, trying to be a good empirical scientist, we looked at, how well do human judges rate these human answers? 99% said that them were rated as grammatical, not too surprising, given we tried to restrict the Turking to be, native speakers or, fluent English speakers in various ways. Then human judges said, well, like 9.5% of them, they were reasonable answers to these why questions. And then we looked at inter-annotator agreement. How much do these judges that judge other human answers agree with each other in terms of their judgments? I guess I said that right. And the classic way to do that is this thing called Fleisch-Kappa for inter-annotator agreement. It's pretty high. They very much agree on the grammaticality and 81.81 Fleisch-Kappa for answer validity. So I think this is quality data. People can answer these. They can evaluate them. They can agree on whether answer is good or not. Okay, so we tried to do a good job of creating a good data set here. Okay, so then we ended up collecting about 30,000 questions from 9,500 stories. Pretty decent size, I would have. Not humongous by today's standards, but decent. One other thing we asked human judges to judge, and I was mentioning in my talk yesterday, I'm not sure if we did human inter-annotator, it's hard to say, as an inter-annotator agreement. We made this distinction with what we called implicit questions or answers and explicit, where explicit means the answer can be extracted directly from the text. Implicit means you really have to just make some inferences and come up with reasons that aren't explicitly stated in the test. And humans sort of said, well, 30% of the time you sort of had to read between the lines is a way that people typically can talk about this in just everyday English. And only 71%, okay, you could sort of find the answer to text. Maybe not an explicit extraction, but at least the information was directly there. And we also looked, why questions are not like the others. I would say there's different, there's not just one right answer. You could have other reasonable ways of explaining why people did things. So we just looked at how much do the different answers for the same why question intersect just at a token level. And it's like 26%. So there's a certain amount of diversity just in the different ways of answering the why question. Okay.
No. Clarification question. Is that 26% unigram?
Yeah, I think so. Yeah. Again, sometimes you get in trouble in these talks as a faculty member because it's a student that knows all the details. I gave a talk at Stanford once, where my former PhD student who actually did the work was in the audience. That was great because if they had a question I couldn't answer, it's Shuba, like, what did you do for that? Unfortunately, Yash isn't here, so I can't do that. So sometimes I might have to say, I don't know. We'd have to get to Yash to get that level of detail, but we can do it offline. Yeah.
Do you create these questions yourself for the humans?
They're automatically generated. We have a little script, good reasonable question. We have a little script that generates pretty good grammatical questions about every event. Why? Those are automatically generated. We don't generate those by hand. Yeah. We just ask about everything in the story. I'm not quite sure.
For example, like you said about the state tensions.
Oh, no, I mean, the data's there. I mean, you'd have to put some ontology on top of it to measure that. So, I mean, the data's there if you can download it and try to do that yourself. But no, we didn't. We did try to do an analysis of the type of question in terms of various things. I took that part out because we didn't get much interesting from that analysis. But you can read the paper. There's just not to get too distracted by this. There's some more details on how we classified the questions into different, whether question about goals or intentions or various things. The details are in the paper if you're more interested in that. Okay. But here's the website for the data set, and you can contact the person who did most of the real work here, Yash, at Stony Brook, for details. But there's the GitHub URL. Not a lot of people have run on this data set yet because it requires actually doing human eval. And don't get me started. I have a long rant about that and we'll get more into it later. But some things you have to do human eval. There's no automated metric that does well. And we'll get to that more in a second. Okay, so initially we tried two, quote, like now today's standards, but pretty small, large models. We tried the base level T5 and unified QA, for those of you who know. We fine-tuned the pre-trained models on Tell Me Why using about 23,000 for train, 3,000 dev. And as with the human answers, we asked 3 human judges to evaluate the system answers on, not quite 500, 450, 464 hidden test questions. And we let them rate both the grammaticality and which are the good answers to the question, the same questions we asked humans to rate human answers. And here's what we got for these in the humans. This is just whether they were positively rated, bit greater than 0 Likert. So it's like, yeah, that was okay or good. Humans are, in the 90s, their answers are rated. But here, these initial models we tried, T5, Unified, they're like maybe a little over 50%. Not so great. We broke this down between all the questions and the ones that you had to reason outside the text to get the answer. And of course, not surprisingly, accuracy dropped. Humans don't drop much at all, right? But the models drop in their ability to answer the question of if humans think the answer isn't directly in the text, and they had to make some inferences to do that. So fine-tuning large QA models as of a year and a half ago was clearly not enough. Automated metrics versus human eval. Evaluating answers to why questions is difficult and I believe really requires human judgment. It's hard to come up with an automated metric for this. We tested 3 automated metrics to compare the generated answers to the human answers, typical thing you would do in MT or whatever. Here we have 3 quote reference answers, right, from 3 different humans, and correlated them with human judgments. And we tested some standard NLP metrics to compare human answers and machine answers, and then some more modern methods that actually are based on pre-trained large language models like BLERT and BERT score. And they don't correlate with human judges very well. They're positively correlated, maybe a mild. I think this sort of correlation, around this is Spearman correlation, maybe around what, looks like 30 or so percent. I think you did not because there's a mild correlation, but not particularly high. So you need to do human eval for this. Now, we give you, if you want to run it, a script that will generate the hits for Turk to put them up. You just have to post them up, pay the money, collect the answers. Does anyone actually want to do this work? No one. I don't even know anybody else who's running this because people are lazy. Okay, breathe. I really went on a rant yesterday at ISI, and I'm trying to control myself today. The people don't want to do human. And is the only way you can write with some of these things. You're not even willing to put in the work. I was mentioning several students today, I've discussed them. I always quote Edison, who said genius is 1% inspiration and 99% what? Somebody must know this. Perspiration, you gotta work hard. Nobody wants to work hard. So they don't want to do human eval. They just want to run a script into the number and put it in their paper and say they beat everybody else. Really, you have to actually do some work, put it up on Turk, do all of this, and you're probably not going to beat us anyway, so why do it? Supposed to be some laughter there. Anyway. Quick score is the most reliable, but none of these are really that great. Okay, that was in the paper a year and a half ago. Now let's move to our more recent paper from last December, EMNLP. Now, how can models use common sense knowledge? So what aspects of common sense knowledge are already accessible or available in these large language models? They do somehow from training on all this huge amount of text, they do incorporate some set of knowledge about the world by doing that. And we'll see, we're trying to measure how much. I'm not denying that they do. I think it's obvious that they do, but it's clearly they don't get everything. They get some common sense knowledge from not processing all this text, but it's still lacking. What aspects could possibly be made accessible by injecting information from relevant other knowledge sources? So what kind of knowledge remain inaccessible? We don't have a good, this is where we tried to quantify or classify different types of questions, analyze what types of questions it was screwing up on, do more error analysis. I cut that part out of this talk because I just felt like we didn't have any real clear conclusions on that. There is more information in the paper if you want to look at it. So size matters. Number 1 lesson in AI, right? The bigger the model, the better performance. More parameters, more data, better numbers. So we went from what I think people usually call T5 base, which is like 110 million parameters. That's like a nano model by today's standards. We at least went up to T5 11 billion, which at least as of, a year ago, when we both was, sort of reasonable. We had to use, that's where we got AI2 wrapped in, because we had to use their compute resources to fine tune this thing, because fine tuning an 11 billion parameter model in your data is not trivial. Then, of course, we had to move to even larger models. There's been a bunch. Of course, now this is dated, or GPT-3, these sort of things. GPT-3 has about 175 billion parameters. You can't fine tune it because it's one joke I always have to say in talks is open AI should be renamed what? Closed AI. You have to do it zero shot. We can get to few shot later if you know which few shot is. Of course, now there's we have the two systems that shall what? Not be named. We'll get back to that. Okay, that's a model size. T5 base we saw not that great. T5 11 billion? Whoa, big improvement. Size matters. GPT-3 zero shot. Not quite apples and apples here, right? This is T5 11 billion fine-tuned on our corpus. This is GPT-3 out of the box, zero shot as it's called. No fine-tuning on in-domain training data. It does a little bit worse, but I would actually argue surprisingly well on this task. Better than I expected. This is on the implicit questions. Again, everybody drops when you have to reason outside the text to get the answer. So larger models do exhibit some aspects of common sense, clearly, because to answer these questions at the smaller model, it has to be learning something about the world. And I'll show you some concrete examples later. But it's still lacking. Okay, how can we add more common sense to these models? Give it some more knowledge that maybe it can't learn directly from text, at least at the scale of GPT-3. How can we use more manually designed, engineered human knowledge bases? This was big in the 80s when I was in grad school. Good old-fashioned AI. How can good old-fashioned AI maybe help this to improve performance on things like light? And so we add code-adding knowledge from this model called Comet. I like Comet. It's it starts with human engineered knowledge bases, Atomic and ConceptNet, where humans have written down rules and knowledge about the world in some abstract form, somewhat quasi-formal representation. And then it actually runs a transformer model that learns to make common sense inferences by training on human knowledge. So it sort of generalizes human common sense knowledge by using a transformer model to learn from human engineered knowledge to be able to make inferences about things. I don't know if anyone knows much about Comet. It's a really nice system out of UW. I like it. And it took us a while to get it to work. We eventually got the knowledge from Comet to help us, as I'll show you. So here's an example. Here's another story I'll quickly read. Sharon slept right through her alarm clock. She was dreaming of the ocean and how the waves sounded. She didn't even hear her family leave for church. When she woke up and everyone was gone, she was afraid. She could move there. So we asked the question, why did Sharon sleep through her alarm clock? You look at Comet. So Comet makes some inferences based on some of the semantic relations in this human-built knowledge that you learned from. And it says, well, maybe it's causes they wake up late. Maybe it has an effect if they get yelled at. Maybe it's hindered by it. It's sort of interesting. You can read the Comet paper about the particular types of semantic relations and how they came up with this. But this is the particularly interesting one, deep sleep, because you look at the human answers to this question. Sharon slept through her alarm clock because she was having a dream about the ocean. Sharon had been sleeping deeply. She was in a deep sleep. What are some one of the inferences from Comet? Person X was in a deep sleep. Directly matches a phrase from the human answer that's not in the story. It's making an inference that is very helpful in answering this question. And that's what we were trying to exploit. Okay. So the paper has a lot of details on, we tried a lot of ways to get this to work, to figure out which inferences from Comet to add, how many of them, because the input buffer to these models is limited, and you can't just take every inference in Comet makes and just cram it into the input. You had to be a little bit selective, how many, which ones. We found that adding the top 3 scoring inference, the most confident inferences from Comet that have different relations. So we get some diversity. You don't just say take effect. You try to sample the three highest ones, but having three different semantic relationships to sort of add to the diversity of knowledge that goes, and then add that into the input to let the language model know about that inference from the knowledge base and use it in its input. Sort of read between the lines and put what you read between the lines and put it back into the story, so to speak. Okay? So we found that again, paper has a lot more details on all of this. We found that adding the knowledge-based inferences to the input story right after the question event used to generate it worked the best for GPT-3, but adding it at the end of the story worked better for T5. Why? Interesting question. I don't know. But we tried different ways, how many inferences to add, which ones to add, where to put them in the story, and came to some conclusions about the best way to do that. Details of all the experiments we ran to try to make these decisions are in the EMNLP 2022 paper. Also, how do you put the knowledge in? You can just put the relation from the knowledge base, but that's like technical terms from Comet. ZeroChat has no chance of understanding it. Fine-tuning, they might learn how to understand effect hindered by whatever these semantic relation types that are in Comet. But we found it better. First, translate that Comet knowledge into sort of ordinary everyday English that the language model can understand. And not surprisingly, that worked the best. So here's the example. I mean, we just put in the formal thing. It says, as last sub-event, person X was in a deep sleep. It's sort of this formal thing. Now, the pre-trains, it might learn how to interpret that, but ZeroChat has no chance. But if we say, Jaren slept right through alarm clock ends with she was in a deep sleep, a little bit weird, but that's how we conveyed this has last sub-event knowledge. Not surprisingly, translating this formal knowledge representation into ordinary English, that was done using a set of templates for each relation, how to express that semantic relation from Comet in ordinary English worked better. So we tried to find the best way, where to read which, knowledge to put in and tried to optimize that. And the details for that are in the paper. This is the implicit results, which of course are always a little bit worse. Or maybe more than a little bit worse. Okay, bottom line, we took our best approach of adding Comet knowledge into these models. And now here I'm showing you a slightly different metric. We switched to this, is the average Likert rating on -2 to 2. This is the average Likert rating between -2 and 2 that a human judge gives to the answers from either a human or the model. And a human gets an average rating of 1.35 to 511 billion. It bumps up when you add verbalized knowledge. And GPT-3 actually this was a little surprising to us, it actually benefited quite a bit from this knowledge from Comet, going from an average like of 1.17 to 1.32, which in the scale of this thing is actually a pretty big jump. Oh my gosh, humans 1.35, this is pretty close. Hey, we're getting somewhat close to human performance by taking one of these, at least as of a year ago, state-of-the-art models, GPT-3, and adding some human knowledge to it as expressed by this Comet knowledge base developed at the University of Washington. But here's the implicit, everybody goes down a little bit. Have we achieved human level performance on this? I'm the eternal skeptic. I was still skeptical. I said, this doesn't really tell me that these models are doing as well as human. Because the average Likert scores are getting close. But what if we binarize? Is it positive or negative? Actually, you do that, and a big performance gap, a fairly big performance gap opens up because the model actually it gets more +2s than humans, but it also gets 0s, -1s, and -2s at a higher rate. And we'll look at the actual distribution across the Likert scale in a minute. But if we just binarize, we say, it was positively rated by humans and negatively rated by humans, right or wrong. And now that opens up this gap. 99% of human answers get a positive rating. Only 89% of GPT-3 plus Comet knowledge answers get rated as positive. It opens up this 10-point gap, which in these sort of metrics, I think is pretty significant because look, invalid, humans almost never generate an invalid answer. Again, we put some filtering in that data, to make sure that it was clean. But, these models are generating a reasonable number of answers that are just humans just rate, thumbs down. Okay? Implicit, not surprisingly, the number of bad answers from the model on questions where you have to reason outside the text, it goes up to 25%. There's still a gap. Why? because here's the percentage of answers rated at each Likert level, -2, -1, -0, 1, and 2. Look at 2. Humans, 44% of answers, humans say, wow, that's really great. 52% of GPT plus Comet, the humans say, that's great. More than humans. Superhuman at this level of just, wow, that's a really great Y answer, right? Oh, but look at ones. Humans are generated better at ones. It's like, yeah, it's a pretty good answer, guy. But 55%. Whoa, zeros, -1s, 1s. 0 for humans, 1%. You're 0. The models are getting more of these lower ratings, and the average goes up because they're getting more of the higher ratings. That's why you have to do the data more. Look at these distributions and they say, oh, average, humans die. Terminator around the corner. Yeah.
Are there answers that also the black and white, the brown?
Yeah, I mean, all it can rely on is the inter-annotator agreement, right? That, there's definitely variance. Reasonable people can disagree, but on average, they pretty much agree on these things. Sure, right. Well, we have 3 human answers. I said there is a fair bit of diversity in this. I think this is another issue that we'd like to look more into, is the diversity of legitimate Y answers. We talked about methods for maybe asking humans to generate more diverse answers, like answer this Y question, but don't answer it the way these 2 other people answered it. Give me another reason or something. And then measuring so diversity is always an issue in generation. Why we don't just care about whether it's a good generation, but being able to generate diverse output. Interesting question, generating diverse answers to Y questions. Interesting topic for future research. Yeah.
I have a question regarding the Likert score for women without knowledge. For the human answers, are we assuming that the common sense that is needed for answering these questions is there across the annotators, or is there a context in which we provide the same?
I think no. I mean, maybe certain knowledge would help you reproduce different human answers. So we're just judging, whether humans like the answer more after you add the knowledge. Whether different knowledge would help match different human answers. Again, I think it's part of the same sort of diversity argument. And yeah, we haven't really looked a lot at that issue. I think that is a good issue for. Maybe different knowledge would help you produce different, more diverse answers. Absolutely. Yeah, highway.
So related question is, are there specific type of question that the GPT-3 do better than?
Yeah, so this is where we tried to break this down. You can look at the analysis in the paper. I had some slides in here. I took them out because we couldn't form any clear conclusions. It was a bit of a mess. So I think that's another issue that deserves more. We really tried on that one. You can look at the analysis in the paper. It's just the conclusions were so inconclusive, that I took it out of the talk. But there's discussion of this in the paper. Okay, this is implicit. Again, the models do even worse on these implicit questions that require reasoning outside the text, reading between the lines, whatever. Okay. Sample, concrete examples here. Highly rated answer from GPT-3 with Comet. Matt and Sarah were pregnant. They wanted to announce it in a fun way. They wrote it on a cake. Then they invited their friends over. When their friends saw the cake, they were excited. Question, why did they write it? Sometimes these automated, generated questions can seem a little bit awkward, I think, like this, but you can still sort of get the gist of it. Oh, the model answer with the knowledge from Comet is to let their friends know that they were expecting a baby. Cool, because it just says pregnant. It doesn't say expect a baby, right? There's some knowledge in there about connection between pregnant and expecting a baby. That's world knowledge that it's gotten. I don't know if that explicitly came from Comet, but if you don't give it Comet, it says they wrote it on a cake. I think that should be negative rating. This is where these exact human ratings, mileage may vary. Human answer is Matt and Susan wanted to surprise their friends with something unexpected. This shows that there's not just one right answer to these Y questions. There's reasonable disagreement about what could be good. Okay, what about common sense in GPT that's not coming from Comet? This is just GPT-3, a highly rated answer, GPT-3, even without comment. Same story, but that's why were Matt and Sarah pregnant. The model actually gives a pretty good answer just straight from GPT-3. No comment knowledge. Matt and Sarah were pregnant because they wanted to have a baby. GPT-3, nice inference from some common sense that you somehow extracted from text. Human answer, the two of them had previously been intimate together. I like how they try to say this in a very nice way. I think a philosopher would call this a proximate cause. This is an ultimate cause, right? But they're different answers. They're both reasonable. I don't know why. The humans actually gave that a +1 because they like these deeper explanations or something, not the proximate cause. They're looking for the ultimate cause. A poorly rated GPT-3 answer. Maggie was drinking some green juice. She left the cup out a while. When she went to get another sip, it tasted odd. She realized that it had separated weirdly. She threw the juice out. Question, why did she leave the cup? Model, Maggie left the cup because it was too heavy. Duh. WTF. -2 human rating. This is a lot. I've seen a lot of these papers now in the newspaper. All these large models, they tend to what? Hallucinate. It hallucinates. Oh, I don't know. The cup was too heavy. Human answer. There was something else Maggie had to attend to for a bit. Much better answer. +1. I don't know. I actually almost give that a +2. Again, you know, the human ratings can vary a little bit. Okay, so now I like to make statements that people can go out and quote me for and cite me. Increase my Google Scholar account. So my conclusion is now, sometimes large language models surprise you how smart they are, and sometimes they surprise you how stupid they are. Now, I am known to be famous for a different quote that I made in an ACL 2014 talk that became a meme, and I have lots of stories about this. You can talk to me offline. I put this statement into my semantic parsing talk. I said, you can't cram the meaning of a whole blankety-blank sentence into a single blankety-blank vector. This has been quoted in a well-selling book, incorrectly, I might add, by Gary Marcus in his book, Rebooting AI. I have to talk to Gary about that. It was meant to be a joke. So, and my colleague Naranjan said, hey, you know, that quote's not going to catch on. There's no fake profanity in it. So I said, okay, Naranjan, how about this? Sometimes large language model surprise you how smart they are, and sometimes they surprise you how blankety-blank stupid they are. And if you don't know it, this stuff actually has a name. My computational linguist colleague in the linguistics department at UT, Katrin Erk, informed me that this sort of stuff has a name. It's called Grolix. I don't know if that one person ever heard this name before. Oh, my former student, that at least at ISI, who hosted me yesterday at ISI, that at least Violet knows. I don't know if anybody else. There's actually a word for this fake profanity based on these symbols. Apparently, it was coined by an actual comic book writer who wanted to have a name. And apparently, there's no decent, I just learned this yesterday. There's no decent etymology for this. It's just like, I don't know, some comic book, I'm going to call this stuff Grolix when you put pound, blah, blah, blah. And then people have put this in titles of papers. Marco Baroni wrote this paper. What can you cram into a pound sign, pound sign, a vector or something like that? So it's a good meme. So this is my new meme. Pass it on. Okay. Two-shot learning. GPT-3 results from zero shot. Anyone who knows the literature knows why are you doing it zero shot? You should be doing it few shot. Very good point. The GPT results are handicapped because they're zero shot, but it's a closed model because it's produced by closed AI. You can't easily fine tune it. So we try few shot in context learning, where we put a few training examples in the prompt. That's been shown to help a lot of problems. Stay tuned, but we've been working on this. Yash has been working on it. Again, there's a lot. When you're doing prompting, you have to do what you have to put a lot of work into. You have to do what prompt blank kind of engineering. We haven't done full prompt engineering on this. There might be a better way, but right now, initially, we can't get few shot to help, which I still don't understand. Few shot should help. Okay, old news, you're sitting there saying, who the hell cares about GPT-3? I care about the systems that shall not be named. you know, the latest system that should not be named actually came out between when I made these slides 4 days ago and today. You know, my God, how do you expect to keep up in NLP? I always tell people, I got 4 more years, I'm retiring, good luck. Another thing, exploring other types of why questions. We're exploring why questions. We're looking into why questions about instructional text. I was telling Violet about this. Why do you do this step before that step? Answering why questions about like recipes or how to change your tire or do sort of WikiHow. We're talking about WikiHow. How do you answer why questions about that? I think that's an interesting question. We're starting to explore that. Preliminary results on explaining the temporal order of steps show that current large language models really do not well. You ask me, why did you do that step before the other step? Not very good at understanding that. But, stay tuned. I think it's an interesting question. Exploring training on other related tasks, we particularly looked at social IQA, question about sort of social reasoning or something. I don't know if anyone knows or maybe even played with social IQA. Can they help tell me why? And can tell me how I help social IQA? And maybe other of these benchmarks that are out there are sort of related. There's some said about questions about fairy tales or something that Josh has been playing with.
We have a fairy tale QA data set.
Okay, yeah, maybe it's yours then. So we're looking at how it can tell me why help these other tasks and how can those other tasks help tell me why. We have some preliminary results, but nothing I can actually, talk about yet. Not because it's secret, just because it's in progress. Okay, so to wrap up here, answering why questions about narratives is an important and challenging problem, I believe. It's something I've worked on since I started my thesis in 1983. So literally 40 years I've been thinking about this question. You might ask, why? Because it's important and interesting. That's my human answer. We have developed a large benchmark data set for this task together with an easily deployed human evaluation framework. Go ahead and do the work. Put up the hits. We've tried to make it as easy as possible. Don't be lazy. Do human eval. Sometimes it's necessary. We developed an approach to adding, so large language models, if you scale them up enough, they can start to do this task reasonably well. Not perfect, but it does surprise me. I've been doing this for 40 years. The extent to which these models can do this still amazes me to some extent. It is amazing what these models can do. You never want to understate what they are capable of, no matter what Gary Marcus and Emily Bender says. That's inside joke for those who get it. So we also developed an approach to adding external common sense knowledge from Comet that you can improve it by adding some human engineered common sense knowledge. Good old fashioned AI can help. The best models produce higher quality answers than humans sometimes, but they also produce more low quality answers because, here the talk, sometimes large models surprise you how what? Like that, and sometimes they surprise you how, we'll leave the profanity out, how stupid they are. Okay, thank you. Good night.
We have plenty of time for questions. Go ahead.
Yeah, thanks for coming to the talk. Thanks for giving the talk. Really appreciate it. Something
I am here, so that was literally correct, but pragmatically inappropriate. My Gricean maxims went off saying that this is inside jokes for the NLP community. Yeah.
Anyway, sorry about that. Something I'm curious about is when you're giving knowledge, I guess, to these LMs, you might be just encoding fairness or bias issues in the pre-existing knowledge that you have. Is that something that you've had a chance to explore?
Yeah, fairness people. I think we have fairness people here that are better than me. Actually, these fact people now because the big conference is fact. So I don't know. Again, this is really outside my area. Maybe somebody else has a better answer to this than me. But to the extent that I want to work on how these large language models themselves incorporate various types of data, maybe because they absorb it from the data they've been trained on, blah, blah, blah. I don't know if this issue has been studied for these human engineered knowledge bases. That's the interesting question that you're answering. And I don't know if anyone's looked at bias in human engineered knowledge bases like, ConceptNet and what's the other thing that Comet was built on? When Comet's built on Atomic, yeah. Does anyone know? I mean,
I think there was a work I'm aware of from USC, also in collaboration with Amazon. I think they showed there are some of these biases in common sense knowledge base.
not surprisingly.
That's just one that I'm aware of.
I know that for large language models, there's a phenomenon called knowledge search, which means I would explain like.
So what do you use?
It's called something called knowledge search. It's like when you train a large enough model with like large.
Oh, this is like this, what do people usually call emergent sort of thing? I've never heard the phrase knowledge search, but emergent's always a word that people use.
Large model and large enough data set. Somehow we're starting to learn like some correlation between knowledge and training on. Do you think training on common sense data set like ask whether the data set they introduce with the product could help smaller models also capture this common sense knowledge?
Yeah. No, I would agree with that. I mean, knowing how humans answer why questions, hopefully learning from that does impart to the model more common sense. I think that's the questionnaire answer, and in which case I would say yes. That's why we want to see, does training on tell me why help social IQA? Is there some general knowledge that it's learning from these tell me why corpus that goes beyond tell me why can help you on other tasks? I think we've got some modestly positive results there right now, but stay tuned. But I think it's an interesting question. Yeah.
Just as a step ahead from tell me why, do we have scenarios like can you do something more like you provide some set of ground rules of how it's more like a fairy tale thing where you change how the world works and you want the model to reason out based.
Wow, yeah, that's trickier. Yeah, like you create a new world where the world there's magic and but that magic only works in certain ways. Yeah, I think that's tricky. I think
I just feel like you saw that the gap is still 10 points and you say that it's there, but what I mean to say is like in humans, the why still goes beyond where we can read these rules and we can still reason why something's happening. But I don't know if a model will still be able to do that.
Probably not. But again, I'm always an empiricist. Try it out. Sometimes these models surprise you how smart they are. They do things that I didn't expect them to be able to do. Where that's coming from, I think it deserves more serious investigation.
Have you tried to ask recursively why?
Wow, no, but we've talked about it. I was actually, I think I told this story. So I don't know if somebody here or somebody at ISI yesterday, I get confused because I make up these stories like, John ordered a pizza. And I go, why did he order a pizza? Because he didn't have any food in his house. Why didn't he have any food in his house? Well, it was a pandemic and he was afraid to go out shopping. Why was it a pandemic? Well, let's not try to answer that question because it will be politically sensitive. So yeah, and we've talked about this. I think it'd be interesting to collect human answers on this recursive why. It's like the kid. Why daddy? Why daddy, mommy, whatever. Why? It's like, shut up and go to bed. There's a famous child book that has some profanity in it or something, right? Go the something to sleep, right? Nobody knows this kid book or something. What? It is out there. Anyway. Yeah.
So have you?
So how can you give us a prediction of how this prompting thing could develop in the future? Because currently all these models are plugged into these models by prompts or like information. Do you see other ways that we could improve these knowledge bases?
Yeah, I mean, I'm happy to brainstorm more. We tried a lot of different things here, but we tried to take the inference from the knowledge base and put it into the input in various ways. And like I said, I didn't go all the details, all the different things we tried. But one thing I was talking to someone else about that actually Agent Troy, when we talked to her about this stuff, came up is let's not take the output of Comet, let's take the hidden layer of Comet. Take the input, take the hidden layer and latent representation of that knowledge and give that into the model somehow. Now, the critical thing there is somehow. But I think there are maybe other, she said they've done something along this, taking the hidden layer from Comet and adding that into improving other tasks, which I think is a really cool idea. We haven't really had a chance to investigate that. So I'm always going to say, hopefully there are other better ways of doing this. But we tried our best. We tried a lot of things And, and we made progress, but I'm certainly hope there are better ways to do this. Yeah. In the back. Oh, I knew it was someone else. I'm sorry. Yeah. Yeah.
Similar to the cursive line, do you have any intuition on like how many like tops of the comment are going to be implicit, like in the implicit knowledge needed for?
That's you're saying recursive on the inference, because we could take the output of Comet and feed it back in as input to Comet. We'll make another inference from that. Now, again, when you start chaining uncertain inferences, we know what happens, it starts to go off the rails at some point because you're just propagating uncertainty and the product of the probabilities, starts multiplying down, right? But I think that's an interesting question that I had not actually thought about. So I'm skeptical that it would help, because I think once you go a couple of hops of this recursive Comet, it's probably going to go to hell. Yeah.
Yeah, so I have a similar questions that have you tried to also give the context of the story to the common sense inference model? Because
very good question. We did look at this issue. There's a thing called paragraph Comet or something like this. This is where I do need Yash here, because we played around with this, didn't get much success, but I'm not going to say you couldn't do better by including more. This actually question did come up yesterday at ISI. So I should have a better answer to this, because it's clearly an obvious question that I haven't thought. I really should talk to Yash about what he did try. We did think about this issue and we did try some things to no success though, but I think it still could bear more investigation.
yeah, and another related question to that is that so did you try that the model also asks why questions, and maybe like, when you try to answer one big why question and break down to several small why questions? You see what I'm saying?
I'm sorry, I don't think I'm fully understanding.
Yeah, so
How are you breaking down the one why question into multiples?
you've seen like GPT-3, right? Like,
What prompt do you give it? Break this question down into smaller questions?
yeah, because some question might be too complicated for the model to answer.
I understand your point. It's sort of chain of thought sort of idea, but who's generating those sequence of questions? You're saying have the human generate that, and like chain of thought style? Can we automate that generation of sub questions? Yeah, so I think it's an interesting question. I want to learn more. I've seen people in the field heard about chain of thought. So that's an area I know a little about, but not as much. But I think trying to apply some of those chain of thought ideas to this corpus could be an interesting avenue also. Yeah.
I've been trying evaluating the large language model's ability as the evaluator. So basically, you have a scenario and then a question and then answer.
No, I like it. Have it just train it to do what we asked the humans to do in the second step.
Yeah.
Right now, we're having to do it with the first step and generate the answer. You're saying train the model to do the judgment of whether an answer is good. I like it. Yeah. And the data's there, you could do that. All the data is there. You could do that. But no, it's a nice idea. I like it.
Okay, maybe two last question, Telly, you can go first, and then we go
I'm
through.
really curious that, were there any like kind of paired negative question, like so for example, why did the girl sleep late, or why didn't the girl wake up early?
So there's counterfactual. What I hear you saying is, did you ask counterfactual questions? Why didn't this happen? No, that's an interesting question, even if it's not your question now. But what is your question?
Partly yes, but probably also I was wondering, like, if you ask the question with a negative way, but trying to evaluate whether the model gives you the consistent.
Oh, I see. If these things are known to not be particularly consistent, you can easily get them to contradict themselves. Famous quote from, what is it? Famous poet, Leaves of Grass. Who wrote Leaves of Grass? Whitman, who said, I contradict myself, therefore I contradict myself. I am large, I contain multitudes. Just to show you I'm literary. That's supposed to be funny. Anyone know this quote? It's a famous quote. Computer scientists are not literate.
Okay, so let's take one last question.
You mentioned that you're able to classify different types of why questions, right? So I'm just wondering what categories did the model perform best?
Well, yeah, as I said, we got messy answers from this. I don't have a clear answer to that. There's some discussion and details of that in the paper. I took it out of the talk because we couldn't get any clear conclusions from that. I agree, it's an interesting question. We tried our best to answer that, but to no avail, unfortunately.
Okay, yeah, so thanks everyone for coming, and let's thank the speaker again.
I don't think